present you today in about 20 minutes how to rig a car in MODO. So first of all, to do this I need a car, which I have here. This is from the MODO content and was provided by Dosh Design, and I've set up a quite simple hierarchy, and we'll inspect that quickly. So for the car to move realistically, I need a few locators, and I made them here. I'll start with the rotation point. With the locator I call rotation point rear. This will be the point where the car rotates around. So if you drive along a street or something like that, then this is the point where the car rotates about. And there is another locator which I call rotation point front, which determines when the front wheel starts steering. And this is what I want to be controlled by the path. So, yeah, first of all, I go into a bit more detail here, what I did with the front wheel suspension. So I set up a locator which holds a brake caliper for the front wheel and the wheel itself, so it can rotate with the caliper still in place. And I need this locator to be at a point where a real car would have this point, so the front wheel would turn realistically like I do here. Okay, so yeah, for the I'm going to read the curvature of the path with this locator here and feed that into the front suspensions of the front wheels. And for that to work, I need to know the distance between those two objects here. So I'm going to go ahead and drag them into my schematic view, which is transform position Z, and I'm going to make a small subassembly which I call wheelbase. Okay, so let's just click on those two here, get the transform channel Z and add them to schematic. Oh, well, that's mistakenly the wrong two ones. Of course not them. Well, I just want to remove them. Remove node. Okay, so this one and position Z and add that to schematic. Okay, so what I've got here is the channels of the Z positions of these two locators, and I'm going to add a measure node and measure the distance of those two. Now I can't drag them directly into here because this is a local channel and this is a world, this is a matrix, so I need to transform that. Matrix construct. Going to duplicate that quickly, Control D, and then wire these up. So, and get an assembly output which I call wheelbase again. Okay, and stick that in here. So I now have the distance between those two locators, which I need to determine how far they should be kept away. So I need to read that out to be able to yeah, of course I could just measure it and feed it into the assembly But if I want to change the car later, which would have another a different wheelbase, I can just move the locators and it would work as well. So I'm going to constrain that to the pass constraint, and I'm going to use this channel here, which I already animated, to control the position on the path of this object. Okay, so I'm going to need to get this one here, and there are two values. One is the path percentage, and one is the path offset. I'll feed some random value in here. Let's say 5%. So this is offset to 5% of the whole path length. So, and I'm going to get this channel to my schematic view and connect this percentage into there. So this channel already is animated, and it is a custom locator I set up with an assembly command. So when I click on it, then I can adjust the position here. Okay, so yeah, and let's just constrain the next one. We go ahead and tell it to sit on the path. Okay, and then I need the path percentage as well, and need to rig that up to my control locator here. So add channel to schematic and connect those two. Okay, now my car moves along that path, but it doesn't turn. And that's because I need to do another constraint for this object here, and I need to constrain that to the front object. Okay, so this is my direction constraint for the front object. Now, since I did not feed any value into the distance here, into the offset, except then 5, this locator would change its position relative to the front or rear wheels if I change the path. So, for example, if I make this longer, all of a sudden my locator here gets in front of the car, and that's not what I want, because I want to control the steering on these wheels, and it should be always in the middle of that. Okay, so I need to calculate the percentage of the offset here, and I can do that by just dividing the path length, dividing the wheelbase by the path length. So I'm going to add a mass modifier divide here, stick the wheelbase into here, and get the length of the path from here, and feed that into the, where is the offset? Well, path offset, we need that here. Okay, so stick that into the offset, and as you can see, it's right in the middle of the front wheels where I want to have it. So now the car turns like it should. So another value I get fed from this rotation constraint is a rotation output, and I can get that into these two locators here, and I need that in rotation Y. Add those two to schematic view, and there is a, that's the right one, yeah. Rotation, oh no. Of course, I can't do that because this is the local position. So I'm going to need to get the world rotation. World rotation at channel to schematic, and for the other one as well. It should be this one. World rotation at the schematic. So now I can connect those two. World rotation. Okay, so once I am here, my wheels start to turn in as well. So the next thing to do is read the car, read the path of the car to feed the rotation of the wheels. So for that I need to know the diameter of one of the wheels to calculate the circumference, and then divide that, then divide the path length by the circumference. Then I have the number of times the wheels need to turn. Yeah, and I'll do a quick sub-assembly here. Call that wheel rotation. Make it active. And for this to work, I need two channels. One is path length. And the other one is percentage. So let's just quickly connect these two, path length in here and the path percentage in there. Okay, double click, and then we can go ahead and rig this up. So I'm going to use this position Y value of this locator here to determine the wheel's diameter. So this by 2, add channel to schematic. This times 2 is my diameter, and this times P will be my circumference. So we say 2 times P and just copy that value and stick it in here somewhere. Mass multiply. So let's just stick that value here, 6.4 almost, 6.28. So the Y position times 6.28 will be the circumference of that wheel, and I need another one to and this, and another one. Multiply. So this is the times the wheels need to turn, and to determine the degrees I need to multiply that by 360. So I'm going to tell that to be 360. Stick that in here. And then I need another multiply node, and I want to multiply that with the path percentage. So what comes out here is the degrees, the value of degrees the wheels need to turn at a given point on the path. So let's stick them in here. That should be rotation X. Add them to the schematic and quickly wire them up. So if I move the slider, what is wrong here? Can't see anything. Must be something wrong with my calculation here. So, oh well. By percentage should work. Rotation X. Ah, yeah. We couldn't see it because it rotates too quickly at that point, okay? So it rotates. And as you can see, the car goes around the bend and automatically steers around. So if I now change the path just by moving some points, and you can see I can change the path, and of course the car follows, and I don't need to care about the steering anymore, and I wouldn't even need to care about the leaning of the car. I could even rig that up based on measured speed and based on the angle, the difference of the angle of the Y angle of this locator here. So if I read that out and fed it into some function, multiplied by percentage and measured speed, then I could make the car lean when it goes through a bend based on how fast it is. So yeah, I think that was about it.
Thanks.
Yes, thanks, Matthias. It was a very nice presentation. And we immediately go forward with Ventus.
Okay.
Okay?
Yep.
Just wire the stuff up.
Just wire that stuff.
Yeah.
No problem.
Wire it up.
Mayday. Ich brauche mal dein HDMI-Dinger.